Immunity to a virus, such as COVID 19, is a multi step method that requires your body's immune system to remember the specific pathogen and how to fight the infection. This is why some vaccines require two doses. The first dose aids in the development of the immune response. The second dose aids in the strengthening of this response and boosts the body's resistance to the virus through activation of memory cells. The two-dose COVID 19 vaccines contain mRNA that instructs your body's cells on how to manufacture the spike protein unique to the new coronavirus. Now, this spike protein is present on the virus's surface. It attaches to and enters a host cell in your body through this spike protein. The body then analyzes all of the information about the spike protein and creates an immune reaction to it, including antibody manufacturing, though this can take up to 2 weeks. The immune system must learn to recognize the antigen, develop antibodies against it, and finally produce memory lymphocytes throughout this time, which comes under the primary response. This is accomplished by B cells proliferating into memory cells and plasma cells. The plasma cells create antibodies while the memory cells hold on to the information of the virus, which causes a generation of memory. The T helper cells also activate cytotoxic T cells, which kill infected cells within the body. This is referred to as cellular immunity. This mix of responses may clear the virus from the body, and if the response is strong enough, can also halt the growth of symptoms to an extreme sickness or stop reinfection altogether. The first vaccine dosage produces a weaker response than the second. As a result, following the second dose, you're more likely to experience negative effects. This is because the initial dose triggers the natural inflammatory response to produce antibodies. But the second dose activates the memory cells that remember the initial dose and have a stronger reaction to the presence of the vaccine. This is also why the second dose is set about 4 weeks after the first, since the antibodies generally last for about that amount of time. Immunological memory has been established at this time, and the immune system can begin producing antibodies right away. This means the amount of antibodies produced is far larger than the first exposure, and it happens much faster. Following a subsequent contact with the same antigen, in this case, the COVID 19 coronavirus, both B and T cells develop a secondary response that is faster and leads to the activation of previously created memory cells, like we've discussed prior. This means that more severe symptoms are often staved off, or reinfection is halted altogether.